Alright, welcome back. This is the Inequalities unit review for Algebra 1 Honors. So let's get started with number 1. Solve and graph negative 3x minus 6 is greater than negative 18. We know that we're just going to do our regular operations to get x by itself, our inverse operations. So we're going to add 6 to both sides. Negative 3x is greater than negative 12. Divide both sides by negative 3, and since we divided by a negative, that sign has to flip, so we get x is less than 4. There's my solution, and then to graph it, remember we're going to put our solution right there somewhere in the middle of the graph. Show me that 0 is on the left side. We're going to have an open circle at 4, and we're going to point left, and we know it's going to be left because if we check a point to the left of 4, like let's say 3, and we plug it back in for x right here, 3 is less than 4 is true, so that means that that is on the solution side. Number 2, given the number line, select the appropriate inequality that satisfies the number line. Show work to justify your answer. So this one, we're given 2 halves of an equation, negative 5 times x minus 2, and 15, and we have to decide which of these inequalities could match to make the graph above. Well, what do we notice about the graph above? We know that we have a closed dot, so it's either a less than or equal to or a greater than or equal to sign. So that means that the less than sign is gone, the greater than sign is gone, the equal sign is gone, because we have an inequality, and when we look at that final answer, it's pointing to the left, which means that x has to be less than some number. And the number, it looks like, which we can't see it on there, but on the actual review, I don't know where the numbers went, but it should be, right here should be a negative 1, so x should be less than negative 1. So what we're going to have to do is solve, less than or equal to negative 1. So we're going to have to actually solve this inequality to see if there's a sign change anywhere. Because remember, that inequality can flip from less than to greater than if we divide by a negative. So what I'm going to do is I'm going to take the 2 halves, and I'm going to write it negative 5 times the quantity x minus 2, and I'm going to leave a big box in 15. I'm not going to fill that box in yet, but I'm going to go ahead and solve this. So I'm going to distribute the negative 5, so negative 5x plus 10, and I want to compare it to the 15. Now I'm going to continue solving like we did the last one. Subtract 10, negative 5x compared to 5, when those cancel out, and my last step is going to be divide by negative 5, and when I do that, I get x and negative 1. Well, I divided by negative 5, so that means my inequality had to flip. I know that my final answer has to be less than or equal, so that means in the step before that, it had to be greater than or equal, which means the step before that had to be greater than or equal, and the step before that had to be greater than or equal. So those were all greater than or equal until I got to the last step where we got less than or equal, because that matches my graph. So go back to my original problem, and the beginning inequality had to be a greater than or equal to sign. Number 3. The Orpheum Theater seats 1,364 people. There are already 576 people that are seated. Write an inequality that can be solved to show the number of people P that can still be seated in the theater. Well, that seems pretty straightforward. We know that there's already 576 plus P must be less than or equal to 1,364. Has to be less than or equal because we can't have more than 1,364 people. Part B now says solve that. So if I have 576 plus P is less than or equal to 1,364, and I subtract the 576, P has to be less than or equal to 1,364 minus 576, and that gives me 788. Since it's a word problem, we need to write out in words what that means. That means 788 people can still be seated. Alright, moving on to number 4. Danielle is purchasing candy from the dulceria. Each candy costs 50 cents. If she purchases at least $10 worth of candy, she gets a coupon that can be used on her next purchase. Write an inequality to model the situation. Notice it doesn't say to solve an inequality, it just says write an inequality. So our inequality, I'm going to use x. I'm going to say that x equals the amount of candy. So my inequality then is going to be 0.50x, so it's 50 cents per piece of candy, times the number of candies, needs to be at least, so that's greater than or equal to $10. There's my inequality. I'm done. How about 5? Jorge got a job as a student tutor this summer. He makes $20 per day, but spends $2 on gas every day he goes to work. Jorge has been accepted to an ASU math camp in July. He needs to save $150 for the camp. Write an inequality representing the number of days that he needs to work to earn at least $150. Well, if we set that up, he makes $20 per day. So how do we represent that? If I let D equal days worked, so 20D is how much he makes in all those days. So if he works 10 days, he makes $200. 20 times 10 would be 200. But then he uses $2 per day in gas. So he's going to do minus 2D. If he works, again, 10 days, he's going to use $20 in gas. So 2 times 10. And all together, he needs to save at least $150. So that needs to be greater than or equal to $150. There's my inequality. Part B, determine how many times he must work to reach his savings goal for the camp. Well, our inequality, 20D minus 2D is greater than or equal to 150. Something that I could have done up here to make my life a little bit easier. We could have combined these like terms to make it 18D is greater than or equal to 150. This would actually be a better answer for part A than the one above. I'll accept either because they're both correct. They're both proper inequalities. But now looking at part B, I'm going to use this 18D is greater than or equal to 150. And we're going to solve that for D, for the number of days. So we're going to divide by 18. So D is greater than or equal to 150 divided by 18. And that number is 8.33. But we can't work 0.33 of a day. It's really 8.3 repeating. So because D has to be greater than or equal to 8.3, we're going to say that he must work at least 9 days. We have to round that up to 9 because we need to be bigger than 8.3. Part C, if Jorge tutors 25 times this summer but spends some of his earnings on a new skateboard that costs $100, determine if Jorge has saved enough money to cover his camp expenses. Well, so we know that in a day, or in working, he gets 18 times D. That's his like total take-home pay after he covers gas. But then he's going to spend $100 of that. And we want to know if that's still greater than or equal to 150. We want to know if he can still cover that cost. So if we plug in what we know, it's $18 times, how many days is he working? We're told it's 25 times, minus the $100 for the skateboard. We want to know if that's still greater than or equal to 150. 18 times 25 is 450, minus the 100 for the skateboard. So 450 minus 100 is 350. So 350 is greater than or equal to 150. Is that true? Is 350 bigger than 150? That answer is yes. Yes, he will have enough money. In fact, he'll have $200 left over. Alright, and then moving on to the next problem. Got number 6, graph the solution of the linear inequality for y is less than or equal to negative x plus 2. So we have a line. It's an inequality, but it's still in linear form. It's still in the form of y equals mx plus b, which means to graph it, we want to find m, and we want to find b. M is the slope. We know this. We've said it about a million times in class. So in this case, m is the thing attached to x, which we see is a negative 1. So m is negative 1. B is the constant by itself, which is a positive 2. And then we graph those two things. So the b tells us where to start, up here at positive 2 on the y-axis. M is negative 1, so I go down 1, right 1, down 1, right 1, down 1, right 1, and I get that nice line. And I know from my sign, less than or equal means it should be a solid line. I'm going to draw my solid line. And that wasn't even close to being the right place. So okay, we'll fix it. And there we go. There's my solid line. And then we have to check a point so that we know which side to shade. Well, the easiest point to check is going to be 0, 0 right there. So we're going to check it. We're going to plug in 0 for y. So 0 is less than or equal to negative 0 for x plus 2. We end up with 0 is less than or equal to 2. That is true. That means that point is true, which means everything on that side of the line is true. So I'm going to shade on that side, and I get that. Number 7, same idea. We need to graph, but before we graph it, we need to make sure that y is by itself. I can see right now it still says negative y. So I'm going to have to rewrite that. Negative y is less than or equal to negative 4x plus 2. I'm going to divide both sides by negative 1. Divide everything by negative 1. So y is now greater than or equal, because I had to flip my sign, 4x minus 2. And now I can find m and I can find b. M is positive 4, b is negative 2. So I'm going to plot those points. Negative 2. And then my slope is positive 4, so I'm going to go up 1, 2, 3, 4 over 1. I don't have enough room to do that again. That's okay, because I don't need to, because I can draw my line from here. And that, no idea why that line is so thick, but that's alright. I'm going to check a point, 0, 0 once again. So when I check that point, I'm going to plug in negative 0. We always check back into the original equation. Negative 0 is less than or equal to negative 4 times 0 plus 2. So I get 0 is less than or equal to 0 plus 2. 0 is less than or equal to 2. That is also true. So I'm going to shade the true side once again, and I'm going to end up shading this time what looks like the left-hand side of my graph. Alright, moving on to number 8. Magali is selling t-shirts and hoodies. She will sell t-shirts for $10.50 and hoodies for $20. In order for her new store to stay in business, Magali must sell $200 per hour. Let X represent the number of t-shirts she sells and Y represent the number of hoodies she sells. Alright, so let's set up an inequality. So if she sells t-shirts for $10.50, the amount of money she makes off of t-shirts is $10.50 times X, because X is the number of t-shirts, plus $20 for a hoodie, so 20, Y, because Y is the number of hoodies she sells, and she must sell 200 per hour, so we need that to be greater than or equal to 200. There's my inequality. Part B, graph the inequality. So if I'm going to graph 10.5x plus 20y is greater than or equal to 200, we could get y by itself, move the x over, divide by the 20, or we talked about in class when we're in standard form, we can simply find the x-intercept and the y-intercept, and use those, just graph those 2 points and draw our line. So the x-intercept in this case means that's going to be down here on the x-axis. It's somewhere along this line. Well, that would be x is my t-shirts. That means I only sold t-shirts. It means I did not sell any hoodies. Well, if I only sold t-shirts, I'd get $10.50 times x has to be greater than or equal to 200 because I didn't sell any hoodies, so I'm just selling t-shirts. So I would divide by 10.5 on both sides. Divided by 10.5. X must be greater than or equal to, I believe it was, when we do that math, 200 divided by 10.5 is 19.05, which we can't sell 19.05 t-shirts, so we're going to round that up. The x must be greater than or equal to 20. So she has to sell at least 20 t-shirts. So that means that there's a closed dot right there at 20, 0. Y-intercept, same thing, but this time I'm only selling hoodies, so the t-shirts part is gone. So I have 0 t-shirts, so I just need to know $20 times how many hoodies is greater than or equal to $200. Well, divide by 20. Y is greater than or equal to 10. I'm going to plot that point now. A closed circle at 0, 10. Now I can connect those 2 dots. And we cannot pass the x or the y-intercept. So we get that, and then we need to sell at least that much. So in class we talked about that this line represented exactly $200. We want to sell more than that, so we want to be above that line. We want to be somewhere out here in the shaded part. If you're not sure which side to shade, again, you could plug in a point, plug in 0, 0 if you wanted to. But we want to sell somewhere out here above that line. So more than 10 t-shirts, or more than 20 t-shirts, more than 10 hoodies. And then part C says select the number of t-shirts and hoodies that would allow Magali to be profitable. So profitable means she makes a profit, means she reaches her goal. So basically anything in that shaded region would work. So I'm going to read the graph and say, well, if I sell 25 t-shirts and I sell 15 hoodies, that puts me somewhere over here, which is in the shaded part. I'm going to say 25 t-shirts and 15 hoodies. And really it can be any combination in the shaded region. Okay? Alright, last page. Number 9, Yogurtini charges according to the total weight of your purchase. If your yogurt weighs between 0 and 1/2 of a pound, the rate is $1.50. If your yogurt weighs over 1/2 of a pound, but no more than 1 pound, the rate is $2.50. And if your item is over a pound, Yogurtini charges $5. So I know part A wants us to complete the piecewise function, but I'm actually going to do part B first. I'm going to zoom out a little bit so I can actually see what I'm doing. We'll stop about right there and actually Not liking that too much, so I'm gonna keep it zoomed in. I'm just gonna have to read the graph. Okay, so and it looks like I had an issue again. Looks like it didn't copy correctly for some reason. So I'm going to modify this graph just a little bit. So we're going to call this, we're going to extend this down. We should have 0.5 right there. Extend this down. That gives me, that's 0. We go across. So for whatever reason, when I imported this, it got cut off. Each one of these tick marks is 1/2 of a pound. So we have our x-axis counting by 1/2 of pounds, and our y-axis is counting by 50 cents. So, alright, so the first part of that sentence says, if your yogurt weighs between 0 and 1/2 a pound, the rate is $1.50. So no matter what our weight is between 0 and 1/2 a pound, the cost is $1.50. Well, that's just going to be a constant. So 0 to 1/2 a pound, that's in this range right here. We have a cost of $1.50. So we have this horizontal line right there. Well, at 0, if we think about this logically, if our weight is 0, it means we don't have any yogurt. If we don't have any yogurt, we aren't paying for any yogurt. So we have an open circle at 0. But at 1/2 of a pound, we still pay the $1.50. So we're going to have a closed circle on that side. Then the next amount says if your yogurt weighs over 1/2 a pound but no more than 1 pound, the rate is $2.50. So between 1/2 of a pound and 1 pound, our rate is $2.50. So see, we're going to use a different color. So between 1/2 a pound and 1 pound, now we're in this range right here. The rate is $2.50. So we're going to have an open circle because it's over 1/2 a pound, but no more than 1 pound, but that includes 1 pound. So we have another horizontal line right there. And then the last statement, if your item is over 1 pound, they charge you $5. So whether it's 1 pound, 2 pounds, 3 pounds, 4 pounds, 5 pounds, it's going to be $5 no matter what. So from 1 pound, which is going to be right here along this line, okay, we go up to $5. It's at 1 pound, we're still paying the $2.50, but anything beyond that, there's our line. Okay, let me draw that a little bit better for you. That's slightly better. Okay, so there's my graph. I have 3 horizontal lines, one going from 0 to 0.5 at the 1.5 for the y value, one between at when y is 2.5, we're between 0.5 and 1, and then we're up here at y equals 5 when we're greater than 1. So now let's write the inequality. So our 3 functions, remember we want to write them in order from as we would read them going across. We're going to start with that blue one. That blue one is just a horizontal line, makes our life super easy. And that horizontal line is just 1.5. That's the cost that we're paying no matter what if our weight is between 0, which we have, and 0.5 ounces. Then the next one is the green line. And that green line, which you can barely see it on the screen, is at 2.5. And we're going to use that one if we're between 0.5 pounds and 1 pound. And notice the inequality is already in there. It was less than and less than or equal. So we have our circles correct, open and closed, open, closed. And the last one, the orange one, we had a rate of $5 whenever x was greater than 1. Alright, and we're almost done. Last problem right here. So we've got graph the function y equals -5 if x is greater than 2 and y is equal to 5 if x is less than or equal to 2. So the line y equals -5, that's a horizontal line. So -5, scroll that up just a little bit. So -5 is a horizontal line through -5. And then the other line was +5. So there's my two lines. And then we only want those two lines in different situations. So when do we want the -5 line, the lower one? Well, we want that line when x is greater than 2, like we can see here. So we go down to the graph. In class, we took out the highlighter and we said, well, here is +2. That's my boundary. So I only want the orange one when x is bigger than that 2. So I'm going to erase everything less than 2. And it says strictly greater than, so we're going to have an open circle right here. And then for the blue line, we want that one when its x is less than or equal to 2. So we're going to go back to our eraser, and at 2, we're going to erase everything bigger than that. And we should have a closed circle right there. So that's what our final graph looks like. And that's going to be it for the inequalities review. Make sure you study. Have a good night.